because what I took from that, I did the interview on theCUBE. theCUBE is a TV show, by the way, so it's an April live streaming TV show, and they go to the events and they interview important people, and then sometimes they interview other people. And so they had asked me to come on and talk about OpenStack, and it really goes to show, I mean, what was it? Hundreds of people descended on Mountain View on a Wednesday and Thursday to talk about infrastructure, right? I mean, we were looking around going, 5 years into this thing, this isn't just technology that we built. This is a movement that we started and that we're all part of, and we're pretty proud of it. So I think that's why I was voted Tech Woman of the Week, because I was talking about the hottest subject in technology today, which is, of course, OpenStack. But if you guys really want to verify, you can go out to CUBE's Twitter handle and favorite and like that video and watch it. Hi, Shane. How are you? Did you have the Tech Woman of the Week this week? Absolutely.
Whenever you're ready, you to share.
I know, huh? I know. No, it's like 1 week to embarrass myself. So I'm also. Yeah. I know. What else can I talk about? But it's actually we're almost done. And we thought we were.
See, I will. I'll share the whole thing.
Oh, seriously? Oh, I thought that's what
Projector
so this is not projecting? What happened to the question that I asked?
You have to put your mouth right up on it.
Okay. I've been accused of not too humble and too quiet. All in the same 5 minutes here. But hopefully Sean test your microphone.
Hello.
Yeah, okay, so you'll be able to hear Sean.
Can you hear me?
No, maybe not.
No?
All right, what's going on here?
How close do I have to get it? Can you hear me now?
Well, yeah, maybe just put it closer.
That kind of ruins the whole
You'll
purpose
need
of having
when
this
you
mic.
guys ask all the hard questions, and please do not let him off the hook. I'm telling you, he's working for
I need a headset like Beyonce. I have one of those?
Yeah.
Do you have one?
No, I
No?
don't.
Okay.
I'm not like Beyonce in really any way.
I think I'm going to have to use that.
001 ways, but maybe so I don't think this one's any better. Although Rick just turned it off. Is that better?
Yeah.
All right.
Oh, better. Okay, from the top. Welcome everybody to our Silicon Valley South Bay OpenStack meetup. Hashtag OSFO. Okay, we're going to start. Sorry about the lack of pepperoni only pizza. We'll get right on that next time. We get the strangest requests, and you know what? It's like no matter what we do, there's always one really bizarre request. Although pepperoni, I'm sure it was an oversight, like or maybe the driver just ate that one on the way here. Anyway, there's I don't have 4 OpenStack shows to tell you about in the next week or two. Thankfully, we're taking a little bit of a break. The next big one is going to be the OpenStack Summit in Tokyo. We're all gearing up for that. I'm excited about it. This is OpenStack Networking Month, as declared by, well, me, because I booked only OpenStack Networking meetups for the month of September. So we've got Sean from Wakanda here this week. We have the group of 100 coming in. You probably met some of them at the Walmart meetup that time. You all remember the field trip to Walmart? You better remember it. There was no beer. Why are you sitting them with thumbs down? There was no beer. So it should be very memorable. Those ours were just forgetfulness. So 2 weeks from now, we have 12 coming in. And actually, they checked the meetup site. They have a pretty cool topic. And I posted the abstract, and I've already forgotten about it. But something about deploying various hypervisors and hopefully like an alternative to VMware, maybe. By the way, Rick Evans, my co-host, now with VMware. Sean Roberts from Wakanda, Dave Lindwell also from Wakanda. Alina and Sylvia are taking care of you guys today from HP. Thank you so much. We love you guys. Are you ready?
I am indeed.
Okay, perfect. Then I can stop babbling. All right, everybody, make sure you give them a hard time.
Much harder time than you always give me. And you want to leave questions at the end, or you want interactive?
Interactive's fine.
Okay, then.
I like interruptions. Can you guys hear me okay on this, or
with the microphone.
should I use that?
It's close. Probably.
It's gonna be a pain
Both?
in the butt to hold that.
I'll pick one.
Yeah, I think you know. Oh yeah, make him stand it there.
Good enough. I think I just disconnected you. There you go. All right. Can you guys hear me?
Yeah.
Nope.
No, sir. You need to hold it right off your mouth.
It's going to make a rude comment, but I'm not going to do it. Okay. Did you guys hear me now? No? Now it's off.
Oh, she
What?
turned it off. She turned it off.
Only having technical run-ins tonight. The previous, we've never had microphone problems.
Well, you turned it off, so it didn't work very well. All right. So everything's better. Maybe I can put it over here. Let me try it again. You guys hear me now? All right. I'll hold it. We'll solve this problem finally once and for all. So, hi, I'm Sean Roberts. Thank you for joining us this evening for the 3-day weekend. So we're here to talk about Neutron Advanced Services. Oops, I apologize. This thing, for some reason, is doing two at a time sometimes. So about me, I'm Sean Roberts. I'm VP of Development at Aconda. I have been an OpenStack board director for a number of years. I retired from that position to work at Aconda. I've worked at Yahoo, VMware, and a few other technology companies. At Aconda, we do open source virtualization, or what a lot of people call SDN. But what we do is a little bit different. It's all open source. And it's actually built by OpenStack operators. It's been running in production at DreamHost for a number of years. So this is not unlike what you may have heard Ceph and the company that it spun out called InkTank has done and has been doing for a number of years. So we're actually very similar. We're also spun out of DreamHost. So key part of what we do at, sorry, I'm going dry already. The key part of what we do at Aconda is we make open source software, and so there is no licensing that we make money off of. So we only exist by making money off service contracts. I'm going to hold this a little bit closer. So so that's basically our business model. So that's why you continue to see us very involved with OpenStack, involved with Neutron, involved with various projects, because it's essentially what we do. Key part of what we do as far as within Aconda is a state machine, and I'll talk about that a little bit more, but that's the key part of how we run and orchestrate Neutron Advanced Services. So what are we going to talk about today? So I'm going to highlight some of the basics about Neutron. I'm going to talk about some advanced services that are in Neutron. And I'm going to talk about what's in the future for a little bit about in general, but also a little bit about what's in store for Neutron in the future. So the basics. Misbehaving. So OSI model. I'm putting this up here just for reference. So if you've been in networking for a while, you start to use terminology as a shorthand. People say L3 and L2 pretty easily, but you don't review the OSI model, at least how it looks. Every once in a while, it has a tendency to confuse people. So we're going to talk about mostly about what Neutron does in L3 and L2, but also the advanced services that I'm talking about typically reside in the L4 to the L7 layer. When you use your browser, you're using something that's using L7. So, a little bit of a, well, not quite an eye chart, but almost there. So it's, so showing, this is just to highlight what we do at Aconda, what our project does. It's running on top of Neutron, so it's not actually interfering with the L2. So we're actually orchestrating the L3 and above services. So that's basically what this is showing, and then I'm just showing the OSI model as a way of comparing that so you understand where it's coming from. All right, so OpenStack, high chart time. So this is all of the what's used to be called integrated projects. We don't use that term anymore, like we don't use the word quantum anymore either. So all these projects have all these interdependencies. And the one we're going to talk about tonight is that one. So that's Neutron. So this is a little bit easier to read. And this is a high level what Neutron is. It's essentially the Neutron server service uses a message queue to communicate with its agents, with the things within Neutron, and it uses an API to communicate outside. It has a database to keep information. Pretty straightforward stuff. So what is the Neutron server? I guess I kind of stole a little bit my own thunder. So the Neutron server is a REST-based API service, an RPC service that's communicating over a message bus, and a variety, and a plugin architecture so that you can plug in other services. Okay, so plugins. I feel like I'm going a little fast. Should I slow down a little bit? Yeah. It's good? Okay. Faster. Yeah, skip it over. Okay. I'll do all those things. So plugins. Plugins essentially add logical resources and make them available to Neutron. It's discovered by Neutron when it starts up. These extensions are available via the REST API. A little bit of what the REST API looks like there. There's a lot of common extensions. Some of those are things that you would expect to see, things that expose extended attributes of ports, quotas, security groups, DHCP, L3. There's some others as well.
What is a port?
It's exposing more attributes than normally you would see.
What kind of attributes?
I don't have them off the top of my head. There's a list. So I'm sorry. The question is, what kind of attributes are exposed by that? And what's that, Parker? I still didn't hear you. Yeah, these are all extensions to the Neutron API. So there is a list of Neutron API extensions. I don't have them memorized, sorry, but they're out there. So there's two types of plugins. Monolith. Well, let's go into them before I. So monolithic plugins are typically called. Well, they're typically vendor plugins, and just putting it simply. So monolithic is a little bit of a pejorative, but I'm not entirely sure if it's meant to be that way, but it's kind of worked out that way. So there's two different kinds of monolithic plugins. There's a proxy style. This typically caches the information in the Neutron database. And then there's direct control. So an example of proxy is NSX, and an example of direct control, which doesn't cache and manipulates the hardware software directly, is, I believe, Contrail is a good example of that. Oh, well, it's being a little, there it goes. I have to throw this thing away. So, yeah, it jumped over that. Okay, back. So, modular plugin, the other kind. It's newer. Some people call it ML2. It's an abbreviation for it. There's two different kinds of things that you plug into it, two different kinds of drivers. There's the type driver, which are typically network states. Flat is probably the one that everyone would be most familiar with, which is exactly what it means. It's a flat network, one big network. There's local for local networks, and then there's VLAN, and there's a couple of encapsulation protocols there as well. So the mechanism driver is basically what it sounds like. It's to access the hardware. So it's utilized by the type drivers to actually manipulate the hardware and set the controls. So Why doesn't everyone just use flat? Well, a lot of people do. But there's drawbacks. You don't have isolation. Everyone wants isolation for various reasons. Some people want it for security. Some people want it for configuration. There's a lot of other reasons as well, but those are the biggies. So if you're using flat, then all the tenants in a cluster are sharing the same network. That's bad to a lot of people, especially if they're security conscious. VLAN, using a VLAN is a little bit better, but you have the isolation on the switch, but it's extremely difficult to manage day one after you've actually set it up, because you have to actually have the switches configured to manage those VLANs just alongside the cluster. So the ideal configuration is to use some kind of encapsulation protocol. I don't think, well, for some of the people in the audience, this is, you've heard about these things, these encapsulation, also called overlay networks. So VXLAN is the latest, greatest, the most sexy one that's out there right now. A lot of people, including ourselves, are using them to create overlay networks. Essentially what it does is what it says up there. It creates an encapsulation of L2 networks, L2 frames in L3 packets. And it makes it so the switches don't have to be configured. This is ideal. So a little pretty picture showing how, no, it doesn't like it. So there it goes. So basically just illustrating that it's between hypervisors on two different switches. It's creating a tunneling across those. So the switches aren't even aware that there's L2 going across them. So that's good. So that was a very brief overview of what Neutron is, the basics. So I'm going to jump into some of the advanced services of Neutron. So load balancing. Load balancing has been around for a while. Hasn't been around quite as long as Neutron, but it is one of the older, more established advanced Neutron services. It's basically there to enable HA proxy, although there's other companies, other products that run load balancing that are very interested in utilizing it, A10 and F5, and there's plenty of other examples. So they're basically using this API extension in Neutron to enable load balancing to make it work. Octavia, as you see the logo up there, is another OpenStack project that aims to use LBAS API extension to make scale-out HA proxy. So they're working on that.
They're actually the new reference.
As of this release?
As of Vancouver.
Oh, right. Okay. So they're the new reference implementation for load balancing. LBAS v2. You're right. Thank you. I'm sorry. Ask that again?
You could use heat to do load balancing.
He can orchestrate a load balancer.
Yeah, heat is basically a template of services. So
What does Octavia give you? Heat doesn't.
you could possibly use, well, his question is, what would you use heat for that Octavia wouldn't do, or the other way around?
Octavia were designed for operators to provide a service to their clients, as opposed to heat being a more customizable templating engine for orchestrating.
So
More driven towards the developer, and one's driven more towards the operator.
So I'll repeat that. So Octavia being driven more towards the operator, where heat is more driven towards the developer. Does that make sense? Did I just say it backwards?
No,
I thought I said it correctly. Yeah, so Octavia is meant to operationalize scale-out HA proxy. That's what it's meant for, where heat is a template of services that you can configure. So you'd use heat when you build stuff. You'd use Octavia to run a cluster of HA proxy. Does that make sense?
Mm-hmm.
Okay. So as David mentioned, Mr. Lenwell, that this is V2. So it's in its second iteration of the LBAS API, and Octavia is the reference implementation for LBAS as of the Kilo release. So there's a couple other services. VPN as a service isn't quite as established as HA proxy, but it does have some implementations out there. It's using OpenSwan as the reference implementation, supports site-to-site, also supports multiple connections per tenant, IKE to set up the tunnels, and IPsec to manage them. This is all pretty common stuff, but the implementation through Neutron is what makes it unique. So firewall as a service, not so established, but it has great potential. So there's been some meetings. Mr. Lenwell was at one of the mid-cycles recently, and it's still in the experimental stage, but there's great hope that we can pull it together and make it into an established project over this next release. So more news soon. So Conda. So what a Conda is doing is, the fancy way of saying it is, a Conda is a multi-process, multi-threaded orchestration service for advanced services. It supports routers right now, so we support L3 at this time, and we aim to support load balancing, VPN, and firewall in the future, as well as other services. So it's designed out of the, it was originally designed to support IPv6, so IPv6 has been in production for a number of years at DreamHost. Supports BGP, supports a lot of other things that operators would need and want to make Neutron work. So right now we're adding some extra features into Conda to make it more operationally stable, so we're scaling out the state machine. We're also building out the infrastructure to support the advanced services. So we're an open source company. We're compatible with OpenStack and Neutron. In fact, we can't run without it. And we're very simple because we're actually running on top of it. We're not actually changing any of it. So any of the last two releases going forward of OpenStack and Neutron, right now that would be Kilo and Juno, we can run on top of that. And we're part of the OpenStack StackForge, soon to be in the OpenStack repo like with everyone else. So we call the state machine the rug. It actually is a play on Big Lebowski. There was a time in DreamHost where a number of projects were Big Lebowski related, so it does tie the services together. So that's kind of the point. It's a little bit of an inside joke. Yeah, go ahead.
You said rug is in the StackForge. I heard that StackForge is moved into OpenStack, so does it mean
You're right.
rug will become the core? One of the modules?
So the question, or the question statement is StackForge going away, and does that mean that a Conda would become the de facto standard? So the first part, yes, it's true. StackForge is going away. I'm not sure how quickly, because there's some holdout projects that will, for various reasons, will be difficult to move. I can talk. Actually, I have a couple of slides on that in a little bit. I can go into detail. Whether or not a Conda becomes a standard, I'd like to say so, but as open source goes, things move sometimes slowly until they move really fast. So I think what we're doing is pretty unique. So yeah, I think eventually it will become, but I don't want to be too arrogant to say that it's going to happen very soon, but hopefully sooner than later. So the state machine, the rug, manages what we call service instances, which are virtual machines, and the state machine controls the configuration, and it also manages the function of the service instance as well. So if those things go down or they get misconfigured, the state machine will fix it. And yeah. So reminder of what reference Neutron looks like. Obviously very high level, missing some things, but this is essentially what it looks like. And what it looks like with Neutron. So, excuse me, with the rug Anaconda. So notice that let me go back a little bit. So notice the L3 agent, the DHCP agent are missing. There's also another service that gets replaced, the metadata agent. So those agents actually their message bus traffic get intercepted by the state machine and gets redirected to the service instance running the routing services. The way that that works right now is that there's a router spun up per tenant, so that makes it a less single point of failure than the existing implementation of either DVR or the stock L3 in Neutron.
Question.
Yes, please.
That message queue that you show there, that's not the main message queue.
It is.
Yes, it is.
Yep. So everything we do in Aconda is just like any other project. I'm not sure how many people have read the 4 opens. It's kind of an OpenStack mantra from the early days, and it was more lore, and then it got codified and written down. But one of those things is to reuse as much as possible. We certainly follow all those things. So we reuse as much as possible. So we use Oslo messaging to access the actual message bus that's part of standard OpenStack implementation. So, pardon? We actually use Ceilometer. We use Ceilometer. So we use Ceilometer to health check the state of the service instance. So that's how it works right now. Yes, please.
So if the service instance previously talked to the message queue, you're hijacking that then?
The question is, are we hijacking the message bus? We're listening in on the message bus, and we're intercepting those messages bound for L3, DHCP, and metadata, and we redirect them to the service instance running for that tenant.
Okay.
So our intention, as we go forward, we'll do that for additional services as well.
So right now, if I understand, the messages that come, if it is related to Ceilometer specific to Neutron, you will pick up rather than Ceilometer, and then you pass on to Ceilometer?
No. So the question was, would we intercept Ceilometer monitoring and redirect it back to Ceilometer? No, we're just utilizing Ceilometer as it exists today to understand the state of the service instance. So that's part of the health checks that we do on those distributed L3 routers. Any more questions?
So
more. Yeah, maybe. Do we have another mic?
No, that's okay. I can talk. And the service instances, right now it includes only the network services, correct?
I'm sorry, repeat the question?
In the service instances you are talking about right now, you include only the network services, like?
Oh, yes. Yeah, so the question was, are we only orchestrating network services? And the answer is yes. So I probably didn't highlight this as much as I could have. So all our project is aiming to do, that's one of the reasons why I think that we're simple in some ways, which is actually a good thing in this case. That all we're trying to do is orchestrate Neutron L3 through L7 services. That's it. Nothing else. Yes, sir.
Hello.
Oh, thank you, Lisa.
So essentially, you just leave the message queue for only do layer 2 work, and you pick everything up after that.
Sure. Yes. Yeah. So you're correct.
Would you like to answer that?
So he was in agreement.
I guess the next question will be: so why don't you pick the L2 also?
Because,
Go ahead, David.
We wanted to remain L2 agnostic so that someone can roll their own L2 solution. If you have expensive switches already in place and you want to come on top of it.
And the point being, implementation is a little bit more difficult for us. Brownfield implementations, we're going to have to make sure that the environment is actually up and running solid. But once it is, we'll be able to maintain the life cycle of those L3 plus services. So we think it's unrealistic. In my experience, it is unrealistic to come into any customer and say, oh, by the way, you have to change that entire network stack. So what you end up with are greenfield deployments, brand new clusters. And that's a way of going, but that's not a really easy way for a customer to spin up new services. It's much easier if you say, well, let's replace part of this. So for OpenStack implementations, that's essentially what we're doing. We're coming in and saying, well, let's orchestrate just this piece of Neutron. We don't want you to necessarily have to change Neutron or change your underlying L2. So the question is, limit to how much bandwidth? You mean as far as what the service instance can handle? Yes, of course there will be. So, just to reiterate the question, is there a limit to the virtual machine, how much throughput it can have? Certainly. So the idea is to spread out the L3 and the other services as much as possible, so that you don't get you're not putting all your traffic in one place, essentially. So what we're doing is we're spreading out the traffic per tenant right now. We're going to spread it out even more, eventually per flow. So there always will be the limitation of what the hypervisor and the Linux kernel is tuned to. That's always going to limit the throughput. We eventually will get to the point where we create specialized appliances running the stack for people that want to run high throughput. But for most implementations, they're looking for operations, not throughput per flow or per tenant. I'm sorry, I can hear you.
Hold on 1 second.
Question continuation.
Oh, hold on a second. Let me finish.
So if I have a HPC workload, that's not.
Oh, yeah. Not so much. So I think eventually, yes, when we go to the appliance model, we will start getting into tuning the kernel and focusing on things like DBTK to make sure that we can push it to the absolute limit and go line rate. But for how we're starting is we're focused more on the operations side of things. Go ahead.
I just walked in. As I was walking in, you were showing that Conda is an open source IPv6 oriented routing service.
Yes.
That it is at layer 3 and routing traffic through firewall and VPN, which are all layer 3 oriented services. What is different about this routing service vis-a-vis other routing services that we know?
Okay. So we aim to support those other advanced services in the future, but right now we support routing. But what makes us different in like a sentence or less is our project is open source. It's part of OpenStack. And all we're doing is we're running L3 services on top of Neutron. We're orchestrating those and running a router per tenant. So that's what makes us different than stock Neutron or some of the other solutions. Does that answer your question? It gives advantage as far as that it's flexible. You can install it today if you're running Neutron, Juno or Kilo. And also it gives you the ability to run a router per tenant, which you can't do in stock Neutron right now. Any other questions?
My question is the service instance in the regular OpenStack virtual machine?
So it's a I'm sorry?
Any Nova resource, container, VM, or
yeah, so what David's saying is it can be any Nova resource, container, bare metal, or VM. By default, we're running a very small VM to run the routers, but we can configure that to be basically anything. We're using Nova and random schedule to randomly schedule the VMs across the cluster.
So my question is, for regular virtual machine is running only like independent network. So in this picture, I would think the RAG is running on control network, right? So how the service instance talk to the RAG?
Yeah, so there's a management port where it manages the service instances through. The state machine also holds the through a bunch of workers that are spun up by threads by the main process, manages the state the configuration of each of those state machines. So does that answer your question? Give me a look like it didn't. What were you looking for?
The service VM also connects to the management network, so that it has a port that can be configured so that the controller can push configuration to it.
I think you were looking for something different because your expression doesn't look like we answered your question. You want to maybe rephrase it? We can come back to it too. I don't want to put you on the spot.
Sean, why don't you go? If you're still planning on showing a demo, let's keep moving. And by the way, for the folks that came in late, over here on the right side of the room is David Linwell, who's also with Akanda. So in case you're wondering who the voice of God is that's piping out over here from the galleys, David is also.
I thought I was the voice of God.
Oh.
Jeez.
Do you want to switch? Do you want to go back to this? And that it's a little bit hard to run around.
Yeah. Okay. I'm flexible.
What did you call this? Ghetto, I think was the word.
Ghetto.
Yeah, let's try that.
No problem.
That'll be easier.
I ain't the police.
Yeah, and also we forgot to mention, so we have a few things we're going to send you home with. Some of you, not everybody, but so for those that were at our fun Lego day and bought all your fun swag and the t-shirts and all of that, please leave the shirts for the folks that weren't there because you already have yours. But if you didn't make it to that, we do have a few extra shirts that we can send you home with, especially if you were late and you didn't get any pizza. That was kind of bad. But this is a little bit more popular of a topic than we thought, or Sean's more popular than we figured out. One of those two.
Thank you. Prabhakar, please.
Question here. You describe drug as a state machine and multitasking and per tenant one. So my question is, per tenant, if I have multiple services, it will support. That's my understanding. Is that right?
Yeah. Yes.
And if it is not that, can I have per service one drug? Per tenant, per service. That is, can I have multiple drugs per tenant?
Multiple drugs per tenant. Yes. So what we are doing right now is we're building out the rug so that it's based on hash rate, and it's going to essentially be a scale out many versions of the rug. Sure, it states many tenants.
Something like we have in Cinder or Zephyr. I'm not sure.
Yeah, it's similar. Not exactly the same, but similar.
So can I assume that Akanda is an offload engine for Neutron server kind of thing?
Offload engine. Yeah, not really.
No, that carries specific connotations.
Yeah,
Accelerating.
And so maybe a correct way of saying what a conduct can enable is it can enable hierarchical port binding utilizing VLANs and VXLAN, which then a switch like a Kima switch running T2 or above then can offload the VXLAN and in-cap, E-cap. So that would be a more, that's about the only way that I could say that we're offloading, helping to offload it.
It can work with an offload engine.
So interesting thing is the service Neutron's service function chaining. We are already seeing some kind of a port and support concepts for binding the services. So can I assume that this I can use for service chaining?
Eventually, yes.
Yeah, it's on our plan.
Okay, so service chaining using anything, including VXLAN, including VLAN, GRE.
Yeah.
Sure. Yes.
Absolutely.
Yeah. So anything, think of anything that Neutron supports, we support. Not going forward to the next release, that will be the case. Right now, we don't support all the advanced services, but we will over this next release. What you'll see is that as Neutron adds new features like service chaining, we'll support it as well. Because obviously, for what we're doing, we want to chain these things together. Additional, as we have multiple services per tenant, we want to chain them.
So can I assume that I can use this conduct? Do you have any APIs? Do you have any APIs for the rug? Or is it rug a Quagga engine inside or something?
No, it's a custom. I'm sorry, David?
Is that what you're asking?
Yeah. There is system. Yeah. And it's
Yeah.
not a routing Quagga engine or something.
No,
It's not a router engine.
HTTP REST API.
Yeah.
You can talk
Thank
to.
you.
There's also
But we're not using Quagga.
talk to the RPC bus as well.
We are running Bird on the service instances to support BGP.
Yeah, because you mentioned it supports IPv4, IPv6, and BGP, then I would assume that it is a routing, an open source routing software like Quagga, Viata, I don't know.
It's Bird.
Huh?
It's Bird.
It's Bird.
Yeah.
Good.
Yeah. Any other questions? One more. This will be the last one. Sorry, Lisa. You already said the last one, isn't it? That one more sneak in. It is football season. You should be able to catch it.
This is a question I don't really fully understand what I'm asking. What I'm asking.
Good qualified. Thank
You
you.
read something about a project called IOVisor,
Yeah, I'm slightly familiar with it. Yeah.
which is also sort of operating at layer 3.
Yeah.
Because of the fact that it is.
iOvisor is using Calico, if I remember right. Is that correct? Isn't it? Yeah. 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 So
My question is, do you intersect with IOVisor at any point? Is there any common ground between you and them?
Yeah. I mean, we're doing some similar things, but we're doing it in a different way. So we're not trying to eliminate L2. We think L2 is going to stay around where Calico is essentially eliminating L2. So I wouldn't be, I want to say this that way, I wouldn't be presumptive enough to go into a possible customer and say, that all L2 you have, you've invested in training and everything else, that's all crap, get rid of that. Certainly top of rack routing is sexy and it's the way to go. And when I was at Yahoo, that is the way that actually Yahoo is redeploying its entire infrastructure on L3 termination top of rack. But that actually takes years for some larger companies to get to that point. It's not a small endeavor. So we will support something similar to that in the future, but we're trying to help the customers as they exist today, which is established L2.
I don't know much about IOVisor, but what I have gathered, one of the things that I understood, and I could be completely wrong, was having layer 3 intelligence sort of centrally available. So that, and that is a powerful idea.
I agree. Yeah, I mean L3 everywhere. I mean it sounds good, but it requires strong infrastructure changes to be able to support something like that. It's if you're starting greenfield, it's certainly an option. If you're brownfield and you have an existing deployment, it's not an option. Unless you're set up that way already. Wow, I don't know of anybody that is. Very few. Or anyway. Okay, so I'm going to continue on where Lisa throws the mic at me. So, a little bit of a highlight. Actually, things have changed a little bit since this slide was created, but this is essentially showing the different states of spinning up a service instance. So that's create VM, create figure, but so it's pretty straightforward. The router, the service instance running the routing L3 manages the data flow, or controls is the correct word, controls the data flow. So this is just I think we kind of touched on this by some of our conversations. Please. Go back. Yeah. What's your question? You get one.
So, what is the calc action?
That's actually just the name of the function in the class. That's a diagram from our code documentation.
I think Doug came up with that. That's probably a Dougism.
Yeah, I think
Doug Hellman used to work for Dreamhost, and he built the first state machine. So
the state machine actually goes through 3 steps to turn a VM on, configure it, and when it figures out what it's doing, that function that it's called is called calc action. What do I do?
yeah, it's like starting state.
Cool. Arbitrary.
So this is pretty straightforward stuff, but it helps to re-illustrate it rather than using words and hand wavy. That east-west traffic is not going to go through a router. It's going to go hypervisor to hypervisor. And north-south traffic would have to go through the router. So, which is a service instance running the routing function. Pretty straightforward stuff, but it just helps to illustrate in the picture what's actually where the traffic goes.
How
So,
does it compare with this? How does
Pardon?
it compare with VDF?
oh, yeah, that's a good question. So the Prabhakar is asking, how does it compare with DVR? So with DVR, you would see these, actually I didn't explain it very well, did I? I just kind of assumed people figured it out. So these little dots are meant to be the service instance. Oops. So these little dots are the service instance, the routing, and they're distributed randomly. That's why you see them weird, outline weird. So in this case, what you see is there would be a little orange dot and every single hypervisor is DVR.
Hey, come here.
So we're only deploying per tenant. So each one of these, essentially, you could say this particular cluster has 4 tenants and it has 4 service instances. And yeah, that's essentially the difference. But more is not better in this case. Because essentially what you end up with is you end up with your L3 distributed all the way throughout your cluster, but also now it means you have to manage it all the way throughout the cluster. So if something goes wrong, you have a lot more things to touch. This case, the state machine is actually managing these 4 objects and making sure that they're doing what they're supposed to be doing. If they don't, it kills it and restarts it. Yes?
So is the east-west traffic all at layer 2?
Yes.
Okay.
Yeah. In this example. Yeah.
Okay, Sean, there's a couple of questions in the Hangout room
Sure.
too, which we're going to ask you. So first one, Conda service VM is L3 traffic hairpins to the VM, which DVR tried to improve.
It's not hair. Well, yeah, I guess technically you could say it's hairpinned temporarily, but if it's quite easy to have the state machine to spin up the service instance in a different VM. In fact, if you spun down the service instance and restarted it, it would definitely show up in a different hypervisor.
Okay, you may already address this, but what kind of communication takes place between a Conda and the Neutron server, and does a Conda leverage Nova to manage the service VMs?
Yes.
Yes.
Yes and yes.
Okay, and then does a Conda do the SRIOD pass-through VMs?
Yeah, we don't currently support SRIOD. We've been talking about it. It'd just be another way of improving the performance. So it's essentially a way of bypassing some of the normal controls in NICs and make it go faster.
You do support SRIOD?
Certainly, yes, true. Good point.
Okay.
Through our partners, we support it.
Full, by the way. This is the first time this has happened. The room is full, and our Hangout is actually full. Like, people are saying, can you please add another one? Crazy, what's going on tonight?
Add
Add
another one. Should be unlimited size, isn't it?
If you know how to fix that, we couldn't figure it out.
Yeah.
If anyone knows how to fix that, let us know.
Well, Hangout on air is supposed to be unlimited size. But, yeah. I can't change it. I don't have that kind of magic. Yeah,
Anyone here can go?
I don't. Okay, so just some highlights on what a Conda is, or where it is. So the source is out on GitHub under StackForge. All the project status and tarballs are out on Launchpad, like any other OpenStack project. Documentation is out on docs.aconda.io. And now I'm going to do something crazy and run a demo. So make sure things haven't broken since I left. Okay.
Excuse me, I was wondering, how much is the project or product changed since May? I've seen a couple.
Well, the good is how much has the product or projects changed since May?
most of our focus has been on stability and HA in our controller. So mostly what's changed is become more robust. And there's a current change which is going to go through probably early next week that supports an open-ended driver for any service. So basically bring your own higher level service and write a driver for it, and Conda will manage the lifecycle. Yeah.
Yeah, so give me a second. Apparently the network crashed while I was...
Feel free to ask any other questions.
So while you were preparing the demo, sorry if this is a stupid question. I'm not an OpenStack guy. I'm just a simple country security engineer. What problem is this actually solving? And that's not meant to be like a criticism or anything. I'm just genuinely trying to understand what is the problem that it's solving.
The main problem that it's solving is simplifying managing routers in a multi-tenant environment. It manages the life cycle and the health status of individual routers in a multi-tenant environment so that if it breaks, it'll just magically fix itself and come back online. In a more traditional environment, you have to get in there and actually troubleshoot and manually manage the service. Where, in this case, if the service stops responding or the network ports go down or the VM that it was running, it disappears for some reason, hypervisor shut off, the rug will notice and will start a new VM on another thing and bring it back to life. So it's sort of like whack-a-mole. Knock it over and stand back up on its own.
So one more quick question, just because we have time.
Sure.
How do you spin that routed image? What distribution are you using? How you send that?
So by default, we're using Debian. We're using disk image builder to build a base image. All that's up under our Conda repo, by the way. You can make your own router image if you want or customize it. Technically, you could run any distro you want. We used to run BSD and we switched to Debian. I'm not sure why, but we did.
Okay. No, there's an open source project called Cloud Router, which is a disk image for exactly that use case.
Yeah.
Source code and everything. So yeah, just curious if you
it would be very easy to write a driver for one,
right.
for any other service, including an alternate router.
Is this meant to be something the service provider runs or the tenant runs?
It'll be something the service provider runs to better control tenant isolation.
Why do you think for tenants is a good idea? If you have 10 or 20 tenants, you are or using
well, I mean that's I don't know why you have 10 nodes and 20 tenants.
I can answer that.
But
it's historical. It's because it's spun out of DreamHost. So most of the configuration, all the original developers, in fact, we're still very closely partnered with DreamHost. It all spun out of DreamHost needs. It's been in production for about 3+ years. And it's a technology not unlike Ceph that DreamHost needed to make things work. So they did the same thing with Conda that they did with Ceph. Thought that other people could use it, so they spun it out into a company. And that's why Conda exists as a separate company, running technology.
I think their question was
that did not answer my question.
Oh, I'm sorry. Well, it's because of DreamHost needs. They wanted to spin up a router per tenant. That was their desire because of the way that they're structured and organized.
Because they're a public cloud.
Sure. Is it the best offer?
It depends on your scale. If you have a tenant cluster with 20 tenants, it might not be the best option, or you might want to run the routers in containers rather than.
Or if you have one really large tenant that has, tens of thousands of virtual machines, that would not be a good model. So going forward, we're going to spread it out so that it's not just per tenant. It has more flexibility than that, but that's why it started that way, because it's a cloud service provider. So, okay, so I'm ready. Network here died on me, but I got things working again. So let me. What's the best way to do this without screwing everything up? Let me turn mirroring on and see if that totally screws everything up. Oh no, it didn't. Yay. Okay. So So what I have up is I have a couple of running SSH into an instance that's running a Conda and an OpenStack cluster. It's a really small one, but it's good for showing the functionality here. So what I have up here is a screen showing the Conda rug service. Actually, I should point. So this thing up here, upper right-hand corner, is the log flowing across for the Conda rug service. This thing down here, kind of mid-right of the screen, is I'm pinging the external interface of the tenant router. So down here in the lower left-hand corner is Horizon, showing that the router is active. This is actually the service tenant. It's not very visible from here, but you have to be an admin to be able to see this. So if you're just a regular user, you can't see the router. That's by design. System visible. Can you guys read it, or actually it changed? That's interesting. It changed the font size. Let me fix that. Please. Is that better?
In the Neutron, we use the external router. External for routing based on the router. We create a router and then we say that it's external and then we connect to the external. So this is which you are showing router. This is actually a Conda router. This is external to Neutron, correct? Yes. And so what is external of Conda versus what is external of Neutron? Are they same? Are they different? How do you engage in a routing for the VMs? So I have a Neutron, okay, and on the Neutron I go and drag and I see the network topology. Yeah. The network topology I have VM, I have it in and just connecting them. So normally we create the Neutron network, net 1, net 2, net 3, create VMs, tell them that hey, I want net 1 and net 3 to be used on this one VM, net 2, net 3 to be used on, and some kind of topology we construct. Yeah. Now those get routed through external. There is external route. Now you are saying this is not seen by the tenant. Tenant doesn't know anything about it, right?
Sean, if you can go in the Horizon and click on the network topology tab.
Yeah, network topology. I would like.
Sure, I can do that. I aim to please.
This looks good. Yeah.
So go to the project.
Yep, I'm good.
What does it look now?
Oh, you don't have any instances?
No, this is just a dummy. There's nothing really running. So I can certainly spin them up, but I'm sorry. I can certainly spin something up, but what are we talking about? I wasn't paying attention.
No, so the topology which I used to see inside the network is that disappearing. Now you are handling.
No, the same tools that you've always used will work because you're just interacting with Neutron. All our router is doing is picking up messages on the regular OpenStack message bus. So it doesn't. As far as anything that's interfacing with Neutron is concerned, there's no change. Okay.
Right. Yeah, you wouldn't
it's
manage Neutron any differently than you do today.
It doesn't know something is outside.
No, it doesn't. Not even aware.
So we are transparent.
Yeah.
Anything that happens, which is F2 most of it. So yeah. External router. This acts like an external router. Okay. Got it.
Yep. So what I'm going to do is trying to minimize these things while still showing something. So what I'm going to do is I'm going to whack the IP table on the service instance. So you see down in the lower right-hand corner that I'm pinging the external interface. You'll see that the log will start spilling across some things as well.
What are you doing in the upper left?
I'm
running a script to break the thing.
Yeah, I'm running a script that's whacking the IP table on the service instance. I'm going in and I'm damaging it over SSH. I'm just not doing it by hand because it's very tedious. So we see that the ICMP is stopped. So in the effort of time, we've been sitting up here for a little while, I'll manually do this. So I'm going to go in and I'm going to update the router with the latest configuration. So it's going to go in and you see that the log is spilling across. And here, before too long, you'll see that ICMP picks up again. So what it's done, if you can read that, it's reapplied the configuration of the router. And it's now the interface is back up.
So are you after knowing that something has gone wrong, are you going and rescheduling it after the scheduler?
It depends on what went wrong. If the VM is alive but the network configuration isn't working, we'll just push the new network, we'll replug all the network ports.
Yeah.
If the VM is dead, then we'll destroy the VM completely. And
so the question was, what are we doing when something goes wrong? It's based on a timer. The state machine will sense when something's wrong depending on what fails. If a route goes down or if the entire instance is unavailable, it'll either rebuild it from image, from glance, or it will reapply the configuration like I just did manually. I did that because I didn't want to wait.
What was the time?
It's configurable. Yeah, it's about 60 seconds right now. Yeah. So I'm gonna crash it. So now I've gone in and I've actually.
You don't want the sessions to be lost.
Yeah.
So my thinking is by getting up in basic and man, that's good. Can that happen really?
Don't know if it would happen that way at the moment. We're in the middle of some changes that will keep a bunch of hot spare routers running in a pool, and then if the router goes down, it can quickly replug the configuration into it, and then it's up almost magically, but it's not ready yet.
Yeah, but you don't need the state machine, right?
No, the state machine will say the same.
So what I did is I basically went in and I killed the kernel on the state machine. I killed it, stated. So you'll see, I'm going to let it actually do its job this time. So you can see the destination host is unreachable now. So looks like, has it picked it up yet?
Yeah.
Yeah, so it will try 3 times. So I think it's already tried once.
Now it's pushing.
Yeah. I can't see very well from over here. So anyway, so what you'll see is, and I can, the Horizons probably recognizes the router's down as well. Yeah, so it thinks it's down. There's a little bit of delay because Horizon caches the data. So via ICMP, it's still unreachable. So it's spinning up the instance from image and glance, just like any other instance. And then it's going to keep trying to apply the configuration before until it responds. And then it will respond with the firmware that it's configured.
Has it been tested for IPv6 and Neutron being kind of things that you use IPv6 for the...
Can. He's not in this demo, but he can.
Yeah, I'm just doing V4 right now. We'll have it die hard.
As a service provider, the kind of recovery times that I'm really interested in are somewhere from sub-second down to almost magic. Things that make TCP sessions valuably start tend to upset lots of people.
So we support VRRP as well. So
router pairs.
Yeah, so you can hot plug a router.
Okay.
I'm not using that for this demo though.
How many service providers?
So then it wouldn't have a failure.
How many people here are service providers? One.
Okay, so
Service providers?
it's back up. So what it did is it see that the log is going to show that there is no more work, and that basically means that it's done. And you see the interface is back up. So it just rebuilt it from scratch. And that's all because of the RUG state machine managed the configuration as last known configuration, just reapplied it after it spun up a new instance. And see now it still thinks it's in build, but that's just because this is delayed. It should show active here in a couple seconds. Nah, it's just cached. Yes.
Sean.
Yes.
Great stuff. I just had a quick question, just kind of related to the HA model. Is there any plans to do some sort of a state synchronize a state from the service instance saving from state so that when you recover it, you can actually rebuild, like maybe, I don't know, firewall or NAC or maybe some routing instance update with state recovery also, or is this planned?
You mean as far as TCP state? Is that what you mean, or what kind of state are you talking about?
So I'm mostly thinking, I don't know, like say if you're doing some sort of a stateful firewall on the routing instance for the outbound traffic, outbound traffic, and if you would say something.
I wouldn't say no, but I think it's likely if we support a stateful firewall, it would probably be some kind of hardware outside of that we would manage the endpoint within the cluster, rather than, because that's pretty expensive service to run. So, yeah, I don't think there's any service that, I mean, going forward over the next release, as we start supporting other services, we're going to build in a library, if you will, of advanced services, not unlike what you do, what's right now for Nova, Cinder, and Neutron. So we want to build in advanced service library for all the rest of the services. So you'll be seeing that over the next 12 months.
Okay, and
so.
He's almost done with it too. It's short. Someone had a question? And also, Sean, are you going to post the slides after this? That was a question.
I'm not done, actually. I stopped in the middle of my slides. I got a couple more things.
Okay.
So one was you said VRRP. So I want to know VRRP between Kanda routers or some external routers where
Conda router.
Yeah,
so,
it'd be a Conda
so you have multiple. If I have one tenant and one per tenant, I have one rug. So you are talking of two rugs.
There's not one rug.
Yeah, there's
a configurable number of rugs running on your cluster. Okay. Minimum of one. If you want HA, you want to have two or more.
Okay.
But then for routers, you get one router per tenant. So one service VM controlled by the rug. The state is managed by the rug per tenant. And you can have two per tenant and use VRRP with them so that you have pairs. So they'll be on different hypervisors. So if one goes down.
So let me summarize for everyone. So you'd have one state machine. Well, the simplest configuration is one state machine, one router pair using VRRP to synchronize them. So rather than having multiple rugs for multiple state machines for each router. As we scale out, we're going to be able to support that, but it's not going to be a one-to-one kind of configuration at that point. That it would be many state machines can manage many routers, but they would be managed as a pair.
The other question is, once you said that you are going to have libraries, is the current library part of Oslo?
I'm using the word library very loosely, so probably definitely misusing it. So how about an index of available advanced services that would normally show up in Neutron? We want to create, essentially we want to manage the lifecycle of the services through service instances managed by a state machine. So for instance, we'd want to see all the different load balancing services that are publicly available as drivers. And then we'd want to also do that with VPN and firewall and hopefully IDS and whatever other endpoints you'd normally have within a cluster.
So
yeah.
That brings to the question that if you are trying to manage, this is all network services after all, right?
Yes, it's only network services, L3+.
In a way, if you look at ODS, our owners or any SDN controller, they really want to control the network services. That's what at least the information model and data models are projected in most of the standard bodies, ONF, etc. is showing up there. So if you try to manage, are you going to adopt any standards in this? You need to manage services after all. And
so the question is, would we adopt something like an ETSI standard or some other NFV standard would be probably the most likely. I don't see why we wouldn't support them. For people that want to run a particular configuration, I don't see that being the standard that most people would use. But I don't see any reason why we wouldn't build out the capability to support something like ETSI or some other standard.
So if that is the stand, can I say that we can take Akanda into OpenNFV, open platform for NFV, and try to make it as a service model,
sure.
standard service model?
Yeah, no, and it's definitely something we've talked about. We wanted to build out some things like we're talking about. We wanted to make the state machine scale out. We wanted to build in the concept of drivers into what we're doing. We wanted to take out some of the very DreamHost specific things that are in the project. This is really our first release that we're working on the second release right now. So there's a lot of kind of build up, startup kind of things that we're working on right now. So as we release Liberty, then you'll see a lot of those things where we're trying to focus more on adding services, less on building the base.
So right now you said you're only up to Kilo, so you are already putting it to Liberty?
Yeah, we're working on Liberty right now.
You're offering in Mammoth, in the libraries and all
so I misused the word library, so we're not supporting libraries, but we are using also libraries, but not the way you're saying.
Liberty release at the Liberty time frame or post Liberty time
frame? You mean
Liberty time frame?
Yeah, we're in the same schedule as the rest of the project, so we'll be releasing Liberty just alongside everyone else.
We developed and test along with Trunk.
Yeah, we're working in Trunk right now. That's
I think good.
Every day we make sure that we're working off master. So I have a few more slides. I kind of jumped in the middle, and this can go as quick as you want, but it was more kind of high level, trying to round out the talk, since I started with talking about the network in a big picture, and then I kind of worked my way up the stack. So I wanted to kind of round it out by talking a little bit about what's going on in the future with OpenStack and Neutron. It's very high level. I'm happy to dive off on tangents if you guys want to. So I'm not sure how many of you heard the concept of the OpenStack Big Tent. It's been debated for well over this last year, and it's been really about, well, it's been about two major things. It's been about improving the release management model of OpenStack to show is probably the wrong word, but to show the way that OpenStack really works today. Originally, there was this concept of incubated and integrated. Really worked well in the early days of OpenStack. StackForge, all those projects were meant to be the incubated place, and if you got into the OpenStack space in GitHub, then you were in the integrated, essentially. That changed over time, and it became very unwieldy, and it became almost a beauty contest. So it was always meant to be a release management structure. So there was a big push to get rid of that and to make OpenStack more like a big tent. That's where the phrase big tent started with. So the idea of tagging came up. It hasn't been implemented yet, but it's actually gone pretty far along now to replace the phraseology that we used originally for incubated and integrated. So there's things focused around function and things focused about release. I bore you guys going into the details. It's inside baseball kind of stuff, but it is moving us towards where we can be able to describe groupings of things that are OpenStack in many different ways, where before we could only really describe them two ways. So as Prabhakar mentioned earlier, StackForge repo is going away. I think the last date, most recent date I heard was October 17th. They want infrastructure team at OpenStack wanted to do away with. I think that's a little optimistic, but but most of the projects will be moved over. Doesn't necessarily mean they're official OpenStack projects. It just means that they're all part of the big tent.
If we have to start a new module in OpenStack, should we do it in big tent? Is there a provision for that in the big tent right now instead of starting in Stack 4?
You're asking about new model. Yeah.
Everyone will be in big tent.
Everyone's in the big tent, yes.
Radical inclusion.
Yep, radical inclusion. That's a good way of summarizing it. So, painful radical inclusion.
Part of the Launchpad, OpenStack, and the big tent? Is OpenStack the big tent under Launchpad? How does it? Launchpad
Oh, yeah. So the question is, how is Launchpad and Big Tent related? Sorry, ask it again.
So normally all the projects which are there in open source have some upstream where they have a source code control, right?
Okay, yeah, they have source control for
Source control. So
projects.
OpenStack is based off that particular.
OpenStack is in Git.
Yeah, so all the code is in GitHub.
On its own
Well,
Git server.
yeah, it's on its own Git, and it's synced with
And
GitHub.
it's synced with GitHub and it's synced with Launchpad. They push tarballs and they push Git repos into Launchpad. But
So-
Launchpad isn't the
Sean, let's stay on topic and here and take the tangent
All right.
until the end.
All right, we'll take it offline. Lisa's trying to keep me honest. So, I think I touched on everything. Well, there is one remaining detail that a lot of projects, including ours, have to go through. So there is the remaining detail of everyone getting the Big Tent trademark, and that's the foundation owns the IP on what is OpenStack, and the OpenStack trademarks are really other than running the biannual events, are really the most valuable thing the foundation owns. They don't want to let it go stale, meaning that if you don't defend your trademark, somebody else takes it and you can't fight them. So, so the foundation is very keen on making sure that the quality of OpenStack and what it means to be an OpenStack project gets defended. So they're going to continue to work on making sure that there's not a trademark being used in an incorrect way, like Quantum is maybe an example. Or Swift, yeah. So it's very likely, it hasn't been finalized, but it's very likely that the foundation is going to require that any project that becomes part of OpenStack and wants to trademark the project, that they own it. There is some discussion about possible, well, that's basically it. I'll just leave it there. So that's a probably inside baseball kind of detail, but it is an important detail. So Neutron Stadium. How many people heard about the decomposition that happened in OpenStack early this year? Not too many people. Yeah, it was pretty traumatic for people that had monolithic plugins in OpenStack. There was a lot of angst, tearing at the hair. So what basically happened is when projects get really large, they get very unwieldy. And there was a variety of problems, but Neutron and Nova have both gone through this, where there's so many people that want to do so many good things that it's really hard to manage all the onslaught of work that's coming in. So the way that the Neutron project decided to manage this is to break out all the plugins into separate repositories, break them out of Neutron. Before the Big Tent, this was pretty traumatic because it meant they all moved into StackForge. Now that under Big Tent, they've all become, essentially with this new model of radical inclusion, they've all become sub-projects under Neutron. There are some rules, but essentially they've all been brought under the Neutron tent, if you will. The common phrase for this is called the stadium, but it's another way of describing another big tent, I guess. And there's shared governance. They've spread out the what's called core reviewer status, so that there's multiple groups across function and across project that now manage that. It's a pretty important detail because it allows for Neutron to accelerate its development, where it was definitely getting stuck because there was just so many people that were trying to pull it in so many directions. Now it has the flexibility to go in all directions to a certain extent. So Neutron. So Neutron has a bunch of different things landing, but I picked out a couple. So IPAM support for third-party address management, support for BGP speakers for dynamic routing. There's been some work about NFV, but there's a ton of work that still needs to be done. Some work around service function chaining. I've looked at, there's about, I think, 8 different blueprints for service chaining. There is a version of it that's landed, but I don't believe it's complete, but it's certainly going in the right direction. And some more functionality around RBAC and enhanced security groups. And there's been just a mass amount of bugs landed this cycle. So those are all good things. Stability is improving, which is what we all need. And certainly, my project needs it because we can't live without Neutron. So it's important. So I have a question slide.
We did have a couple more questions.
Yeah, please. Now's a good time.
Hang on a second. These guys have been waiting to ask.
Yeah.
That's okay. It was actually kind of more a comment than a question, but it's really interesting to see the use of the term SDN in this context because it's such an overloaded term, but I like it that you're applying it broadly. And a lot of the kind of work that I'm seeing around OpenStack and Open Daylight SDN is focused on within a compute cluster. So you're looking at local area software-defined networking. I think the interesting area, and I don't know whether you guys are looking at this, because you already have layer 3, you mentioned you're using the Bird BGP speaker, which personally I think is awesome. It's the only BGP speaker ever. It's never had a security vulnerability. That's a fact. And anyway, so I think there's a lot of, tell me if you got one, because I can't find one.
Okay. He was being superstitious, but unfortunately I don't think it's wood. Because
anyway,
sorry, plastic.
Not to ramble, but I think there's a lot of scope for you to use this to extend this in the future to more of a wide area networking functionality.
Absolutely.
And
Sure.
personally, I've been working on a platform for doing exactly that, for wide area SDN. And if anybody's interested in hearing about that later on, I've got some free tickets to an event. We'll be talking about it in more detail on September the 9th. So I'll leave it at that. If anyone wants to hit me up afterwards, feel free.
The event on September 9th?
It's a launch of the product that I've been working on, which is called Console.
Cool.
Your own personal launch of your company, or is tied to a bigger networking event?
Akin na rin ko na, pagkukulat natin ang itacheto